Hi, welcome to lesson 13 of our geography series. In today's class, we will learn about atmospheric circulation. Okay, in previous classes, we have learned about distribution of temperature, how temperature is received by the earth and how it is radiated back from the earth, and how this distribution of temperature is affected by various factors of earth, that is rotation, revolution, the inclination of sun's rays through various reliefs on the earth. Based upon all this, how the temperature is distributed and effects caused by this temperature we have discussed in the previous classes. Okay, and now coming to atmospheric circulation. Atmospheric circulation is nothing but some constituents are circulating in the atmosphere. What are that some constituents? It is the wind. What is wind? Air set in motion is called as wind. What is air? Air is a it is a constituent which consists of gases, water vapor, and dust particles. It is air. Okay. When it is set in motion, when it moves horizontally, it is called as wind. Okay. The circulation of this wind in atmosphere is called as atmospheric circulation. It circulates from equator to poles based upon the pressure belts that are formed in each of the regions. That is, in equator it might be low pressure. In temperate regions it might be high pressure. I am saying it might be. We look into what pressure belts are formed at what latitudes. We look into it. Okay. Yeah. So in previous class we have learned about temperatures, and now to learn about atmospheric circulation, we should learn about pressures. Okay. So due to this atmospheric circulation, the wind is set in motion. The wind rises up, condenses, and falls as precipitation. And all the weather patterns happen due to atmospheric circulation only. Precipitation is one of the weather pattern. Okay. So to learn about atmospheric circulation, first we have to learn how pressure develops and how this pressure behaves. Okay. Let's look into it. Pressure. We have discussed in the first class of climatology that there will be temperature induced pressure. That means high temperature areas experience low pressure. Areas having low temperature experience high pressures. Okay. In according to Boyle's law or Gay-Lussac's law, pressures are directly proportional to temperature. Okay. These are for liquids, but here we are talking about gases, and that too in a particular scenario that is called as climate. In climatic scenario, pressures are not directly proportional to temperature. Pressures are directly proportional to temperature in case of liquids according to Boyle's law and Gay-Lussac's law. Okay, but when it coming to specific scenario of climatology, the pressures are induced by the temperatures. So high temperatures induce low pressure, low temperatures induce high pressures. Why? We have discussed in the first class. Please look into please go back to that class and understand the logic behind it. Okay, this is about temperature induced pressure. Okay, and secondly, what happens due to this temperature induced pressures? Pressure travels from high pressure areas to low pressure areas. Okay, due to this temperature induced pressures, a gradient develops, that is high pressure areas and low pressure areas, and pressure travels from high pressure areas to low pressure areas, setting the air in motion, that is wind. Okay, due to this pressure gradients, air was set in motion, and with the air with it while the air is set in motion, it is called as wind. And wind while traveling, it carries with it water vapor, temperature, and air masses with it, and influences weather patterns of certain areas. While wind is traveling, It takes with it some amount of water vapor at the originated area, or some amount of temperature, so it distributes temperature on the whole earth. Okay, and air masses if present. Okay, the wind carries with it and influences the weather scenario or weather patterns of certain parts of the earth. Okay, and we are saying wind travels from high pressure areas to low pressure areas. So it can be vertical or horizontal. Okay, the air set in motion in horizontal way is called as wind. And scientists or climatologists were saying that the pressure differences, high pressure and low pressure differences, were very much high in vertical. When we take a vertical scenario, that means it is a sea level and it is a cliff. So the pressure differences here, as we move up, pressure decreases. Why? I will explain it to you. As we move up, pressure decreases. So it would be a high pressure area and it would be a low pressure area. Okay, whenever due to this, but the pressure difference horizontal is less compared to vertical pressure gradient. Okay, but we cannot see strong upward winds. Only we can see winds that are moving in horizontal way, but we cannot see strong upward winds. That is winds traveling, in a vertical way from high pressure to low pressure, or from high altitude to low altitudes. Also, we don't see winds traveling in vertical directions. We only see traveling them in horizontal directions. Okay. Why this vertical direction of wind is not being seen? Because when our wind travels in a vertical way, the velocity of the wind is cancelled by the gravitational attraction of the earth. Okay, when our wind is traveling in a vertical way, it is pulled down or attracted towards the earth by the gravitational attraction. Hence, this vertical velocity of the wind is cancelled. So we cannot see strong upward winds. Winds only happen in a horizontal way, that is high pressure to low pressure area. And next, here we said that as height increases, pressure decreases. Why? So if you take a column of air, it is at sea level, it is at mountain level. The air present in this column and certain air is present in this column. Okay, the air present here is I don't say subsided, it is compressed downwards due to gravitational pull of the earth. So it stays here and high pressure is observed here. High pressure observed here means if a man is standing here, as the gravitational force is attracting the air towards the surface of the earth, from upper layers he experiences more pressure of air falling on him. Okay, but as if man is standing here, there is not much air present here to induce pressure upon him. Okay, at higher levels there is no much upper layers of air that induces pressure upon him. So here he experiences low pressure, and at sea levels he experiences high pressure. Okay, that's why pressure decreases with the increasing height. Because the amount of air as we move upwards decreases. See, we often see that trekkers while traveling to higher summits, they are induced to certain conditions of low amount of oxygen and they die. Particularly these kind of accidents happen in Mount Everest trekking adventures. Why? Because there is very less amount of air at the summit and very less amount of air to breathe in, so that low amounts of oxygen will be there. and that's why they carry a cylinder, oxygen cylinders with them while trekking or while usurping the Mount Everest peaks, because the low amount of air is present at the higher levels of atmosphere. Okay, lower levels of atmosphere, more air is present, more we can experience more amount of air because the gravity is always pulling it down. So above our head we have air that is compressing us down. Okay, so this is about air pressure. So due to these pressures, we said that air is set in motion from high pressure areas to low pressure areas. Okay, so this wind is set in motion. Anything set in motion will have a velocity, and this velocity of the wind is affected by various factors. Okay, first one is pressure gradient. Right, pressure gradient. So what is pressure? The difference of the pressures between high pressure area and low pressure area is called as pressure gradient. Whenever this pressure gradient is high, wind travels in much faster area. Like let's say pressures are measured in with a unit called as millibar. Let's say here it is 1000 millibar, and here it is let's say 600 millibar. So wind travels in much faster way from high pressure area to low pressure area, and it is 800. So wind travels in a much with much less velocity from high pressure area to low pressure area. So that's why I will explain it again when we are discussing cyclones topic. So whenever cyclones happen, a low pressure area develops. Okay, due to this the low pressure area is very extreme, that the winds coming from high pressure area intensifies this low pressure area. Winds come from high pressure area to low pressure area, and this low pressure areas gets intensified and travels upwards, form as clouds and precipitates as cyclone. So the low pressure is like it's very much low, that it attracts strong gushing winds from all the high pressure area directions. Okay, that's why cyclones are very intense in nature, due to the the magnitude of lowerness in the lower pressure is very much high. The lowerness is very much high, so that they attract more amount of winds towards them. Okay, that's why the cyclone intensifies. Okay, yeah, I will explain it when I come to cyclones chapter. In order to understand it, you have to understand pressure belts first. So for now, due to pressure gradient, more is the gradient, more faster the wind travels. Okay, so why these pressure gradients are developed? Due to temperatures, right? High temperatures area, low pressures are developed. Low temperature areas, high pressures are developed, right? Yeah. That is pressure gradient. Second is frictional force. Whenever a wind is set in horizontal motion, okay, it travels seamlessly when there are no obstacles. When there are obstacles, the direction of the wind changes. Okay, for example, if you take Cherrapunji area, what happens? Monsoon winds blow into Cherrapunji area. Due to the setting up of mountains in that area, what happens? There is a we call it as funneling effect. Once the monsoon winds center here, they hit this mountain, and again its direction changes, hit this mountain, again direction changes, hit this mountain, and there is a gradual funneling effect happens in that area, and these winds rise up and fall as rain. So there are more amount of rains in Cherrapunji area due to this funneling effect. Why this funneling effect happens? Due to friction caused by the mountains. The direction of the wind is changing due to friction. The wind is blowing in one direction, hits mountain, changes its direction. But this friction is experienced from the surface of that 1 to 3 kilometers from the surface of the earth. Beyond 3 kilometers, there are no much relief features that is affecting the direction of the wind. Okay, it can be experienced from 1 to 3 kilometers from the surface of the earth. Due to relief or obstacles, the direction of the wind changes. Okay, or the velocity of the wind also changes as it is hitting. The speed of the wind also decreases. Okay, third one is the most important. It is Coriolis force. Generally speaking, Coriolis is not a force, it is an effect. Why it is an effect? Because it whenever you apply a force, you either increase whenever you apply force on certain mass, you either increase its velocity or decrease its velocity. Okay. For example, a object is moving and you're pushing with a force, so its velocity increases. Whenever object is moving, you are pulling it back with the force, so that its velocity decreases. So what happens, whenever a force is applied on a certain mass, its velocity changes. But due to Coriolis effect, the direction of the wind changes. There is no change in the velocity of the wind, so it is called as Coriolis effect rather than a Coriolis force. Okay, that is first thing. Second thing, why we experience Coriolis effect on the wind? Because of the rotation of the earth. Because of the rotation of the earth, winds are deflected. Because of rotation of the earth from west to east, that is in anti-clockwise direction, winds are deflected. So now we understand what this Coriolis effect is. Okay, see. It is equatorial region, it is polar region. There is an object here, there is an object here. Okay. Next. It takes 24 hours for this object to travel entire earth and reach this point. And at the same time, it takes 24 hours for this object. Let's say it is B, let's say it is A, it is polar region, it is equatorial region. Okay, whenever point A is set in motion, it takes 24 hours for point A to reach this exact point again. Okay, and for B, it also takes 24 hours to reach this point B. When B is set in motion, it takes 24 hours for B to reach this point. Okay, this is one thing. Secondly, we can say that at equatorial, earth is bulged, so more area is at equator, but at polar, earth is not bulged, it's rather flat, so less area is to be covered at the poles. But B is taking same 24 hours for covering less amount of area, and A is taking 24 hours for covering more amount of area. So we can say that A is moving faster compared to B. So it implies that rotational speed is high at equator. And rotational speed is low at poles. And also we can say that as we move from equator to poles, rotational speed of the earth decreases, right? Please keep that in mind. Okay, it's very much important. And what is the third conclusion we can draw from it? So, for example, let's say it is northern hemisphere and it is polar area and it is equatorial area. Whenever wind travels from higher latitudes to polar area, what happens? Here the earth is rotating faster. So whenever an object is trying to move from polar to uh, towards equator, what happens? Due to less rotational speed at the higher latitudes, it deflects behind the equator. So it deflects rightwards. Okay, and whenever wind travels from equator to poles, due to more speed at equators, it deflects ahead, that is right. So we can say that winds deflect rightward in northern hemisphere. Why? Due to Coriolis effect. Why this Coriolis effect is why this Coriolis effect is experiencing is influencing on earth? Because of rotation of the earth. Okay, due to the differential rotational speeds of the earth, Coriolis effect is induced, and due to this Coriolis effect, winds are deflecting right side in northern hemisphere. Why right side? I have explained. Whenever winds moving from higher latitudes to lower latitudes, the winds at lower latitudes travel much faster due to due to more rotational speed. Whenever it travels from higher to lower, it deflects behind the lower latitude. So from in this perspective, this is the right. Whenever winds traveling from equator towards the poles, what happened? The winds deflect again right only, that is ahead of the polar areas. Okay, because the rotation speed is more, it travels much faster, so it deflects rightward or ahead, we say. This is in northern hemisphere. So similarly we take southern hemisphere. So it is equator, polar area. Again here high speed, here low speed. So wind traveling from low speed area to high speed area. So what happens? It deflects behind. Earth is traveling in this direction, so it deflects behind. From here it is deflecting behind, that means it is left. Similarly, when wind traveling from equator to poles, that is low speed area to high speed area, what happens? It deflects ahead, it is also left. Okay, so we say that winds deflect left in southern hemisphere due to Coriolis force. So this is why this Coriolis effect is induced on earth, due to differential rotational speeds at the equator and at the poles. Secondly, due to this Coriolis effect, how does winds are deflecting in northern hemisphere and southern hemisphere? Winds are deflecting rightward in northern hemisphere and leftward in southern hemisphere. And another factor, Coriolis effect always it affects the winds in like perpendicular way. So whenever wind is traveling, due to Coriolis effect, what happens? The wind deflects at 90 degrees. Okay, Coriolis effect acts perpendicular to the direction of the wind. So wind is traveling in this direction. So due to Coriolis effect, the wind deflects either here or like this, and with this direction it makes 90 degrees. So we can say that Coriolis effect acts perpendicular to the direction of the wind. So due to this perpendicular acting of the Coriolis effect, winds circulate clockwise in, not only winds, this Coriolis effect can be seen on each and every object of the earth in northern hemisphere and southern hemisphere. For best example, for birds and airplanes. Okay, see, let's take northern hemisphere. Whenever an object moving from equator to poles, what happens? It deflects rightward, and rightward, that in a perpendicular way. So here it direction changes here. Now again from here, due to Coriolis effect, what happens? Again it deflects rightward. what is right here, here. So it deflects like this. Again Coriolis effect is induced, and again it deflects rightward, that is here. Sorry. So it deflects here. Okay. Again it deflects like this. So there is a clockwise direction of the objects or winds in northern hemisphere. So, and due to leftward deflection of winds in southern hemisphere, there would be anti-clockwise direction, that is circulation, anti-clockwise circulation, sorry. So whenever it is moving from here to here, what happens, it deflects leftward. Okay, and again it deflects leftward, and again it deflects leftward, and again it deflects leftward. So there is a anti-clockwise in southern hemisphere and clockwise in northern hemisphere. The wind circulate clockwise in northern hemisphere and anti-clockwise in southern hemisphere. And another factor of Coriolis effect is Coriolis effect is zero at equator. So that means in equator, let's say it is equator, wind is blowing, and due to earth is rotating from west to east, so wind also moves from west to east. There is no deflection at equator. Okay, why there is no deflection at the equator? See, we are saying that earth is tilted. Earth is tilted in such a way that if this is earth, let's say let's imagine a balloon or a ball, and fix two pins at both the poles of the ball, that is at northern and southern. You fix them and you rotate. Okay, the ball rotates along the axis of the pin. Okay, if these are pins, what happens? The ball rotates along the axis of the pins. So as the earth is tilted, okay, so the axis, this axis makes certain angles with the earth. Okay, the tilt, okay, if you the earth is rotating in west to east direction, so there is a plane of motion for it. See, in a circle, if if certain thing is circulating in a certain manner, we say it's plane. It is circulating in a certain plane. It is its plane. It's okay. Likewise, whenever the earth is rotating in a tilted way, it will have some plane of rotation. So that plane of rotation will make angles with the tilt. Okay. And what happens at equator? The angle made with the tilt is zero at the equator. Okay, the angle made with the tilt is zero with the equator. So with the axis, the more tilted you are, that is at polar there is more tilt. While coming to equator, the tilt reduces. Okay, at polar there will be more tilt, and as you come to equator, the tilt reduces, and from equator to again southern pole, the tilt increases. Okay, that's why certain parts of southern hemisphere and certain parts of northern hemisphere comes under the influence of the sun. So the more tilted you are with the axis of the earth, the stronger the the sidewards force. Okay, the more tilted you are with the rotation of the earth, so that is spinning axis of the earth, rotational axis of the earth, the more is the sideward force. But when you come to equator, the tilt is zero. uh, tilt is 0 in relative to rotational motion or the rotational axis of the earth. Okay, that is one thing. And another thing is the rotational motion at equator is similar to the circumference of the earth, so it does not make any angle. When will be the motion is similar to circumference? When it's not making any angle, without any deflection. When something moves without any deflection, it covers the area within a certain period of time, and that certain period of time is the rotation of the earth. According to rotation only, the objects in the equator move, because the rotational speed and the circumference are they are matching each other due to the, because why they are matching with each other, because there is no tilt at the equator. No tilt at the equator, no sideways force, so no deflection, so no Coriolis force at the equator. And at polar region and higher latitudes region, the tilt is more with the rotational axis, so the winds deflect sideways, that is either left or right. But at the equator, the tilt is 0. So tilt is 0, and also the rotational speed at the equator is equal to circumference of the earth, and thus it does not make any angles with it. So it does not make any deflections with the earth axis. So the winds also does not experience any deflection, okay, at the equator. So this is Coriolis effect. Note down the points in a chronological way. What is Coriolis effect? Why this Coriolis effect is happening? Okay, what happens when Coriolis effect is induced on winds? Why Coriolis effect is 0 at equator? Okay, so due to these factors that I have explained, the direction and velocity of the wind is changed. So that's all for today. In next class, we will see due to this Coriolis effect, how winds are traveling in the atmosphere, and how different pressure belts are formed at different parts of the earth, and how it is influencing the world climate. Okay, yeah, that's all for today, guys. Yeah, if you have any doubts, please do let me know in the comments. And time and again I am saying that please do revise these topics in a periodic way. Why means you often forget these logics if you don't visit it often. And when it comes to climatology, this Coriolis force is very much important. So you make sure that you understand this Coriolis force. Make sure that you know how winds are deflecting in southern hemisphere and northern hemisphere. Why they are deflecting? It is important to know why they are deflecting, so that you can draw these pressure belts whenever you are asked to do, and it would be much easier for you to answer questions in prelims and mains also. Okay, yeah, thank you.